Hello everyone, let me tell you a story about twin brothers Scientify and Dumbify who were separated at birth. Scientify was the scientifically minded one and Dumbify was, well, let's just say less so. Scientify lived on Earth and Dumbify somehow landed on star Sirius 9 light years away from Earth. However, Einstein noticed a strange phenomenon with the brothers. If one raised his right hand, the other would always simultaneously raise his left hand and vice versa, apparently communicating at a speed faster than that of light. Einstein dubbed it spooky action at a distance. This is a good time to bring in the weird concept of quantum entanglement. Much like our brothers who were entangled due to their birth, quantum particles such as photons can be entangled by a process known as spontaneous down conversion, in which a single photon fired through a crystal emits two entangled photons. Much like our twins, these photons have a bond which makes them communicate even millions of light years apart. Like the twins, entangled quantum particles are always obtained with opposite spins. According to the law of superposition of states, quantum particles can exist in two states simultaneously until a measurement is taken which forces them to choose one state. This means that for an entangled pair, both particles exist in both states until their measurement is taken. When the spin of one particle is determined, the other particle instantly takes the opposite state, no matter how far the particles are from each other, just like Scientify and Dumbify's communication 9 light years apart. So either information travels faster than the speed of light between the photons, something Einstein ruled out, or there is hidden information contained in the photons which allows them to take predetermined states. Experiments designed by Bell have proven that there is no hidden information, and indeed these particles were somehow able to communicate at a speed faster than that of light. That obviously means a lot of unhappy scientists. Quantum entanglement finds real-world applications in quantum computers, in cryptography, where eavesdroppers are detected easily as they cause a change of state of the entangled photon which works as the private key. And even microscopes. Using entangled photons, Japanese scientists created a microscope which was able to create a sharp image of the letter Q raised by only 17 nanometers. This was achieved by a more accurate measurement of optical paths using information from one photon about its entangled counterpart. Fun fact, some scientists believe that quantum entanglement makes birds such great navigators. Quantum entanglement is changing the way we understand the universe, while also being able to create amazing technological advancements in our physical world.